Alright, so hello and welcome. Back at another problem to solve. I've been kind of all over the place lately, so I haven't really been solving too many problems recently. But yeah, we'll get back to it soon enough, I guess. There are a couple other things on the horizon right now that I'm also like really distracted. Been listening to the Bible quite a bit, and just, I don't know, thinking about other things, thinking about God quite a bit. Anyway, yeah. So let me get into this problem. So we're going to look at. So I should mention I've already looked at this question. Yeah, it's kind of not a long story, but what I've been doing is like I'm trying to get a little more sunlight. So I'll go outside and kind of sit down and either read the Bible or just like pull out my phone and just read some of these hard questions. They're not really that hard, ultimately. The hard questions. A lot of them I've seen before and I've worked on them, and like I'm pretty sure I can solve these questions pretty quickly. There is one question that is interesting, and that is the trapping rainwater. That's an interesting one. We'll go over that one, I think, maybe later. But anyway, longest valid parentheses. All right, we'll just try to solve this just to have it done and kind of be on our way. Given a string containing just the characters opening parentheses and closing parentheses, find the length of the longest valid well-formed parentheses substring. So input is like open, open, close. It's 2, right? Because this one is open, is the longest one. And then close, open, close, open, close, close. Gives you 4 because this one is the longest valid. And then if it's empty, it starts out, you just get 0. The length is 30,000, and every character is either one or the other. Alright, so this is super simple, the way to do this. So I'll just explain it. So basically use 2 stacks, and 1 stack. You keep track of, and we can actually use a vector for both of these. 2 stacks, one stack keeps track of the characters themselves, and you can use booleans, just zeros or ones. So a 0, you would push a new opening parentheses, you'd push onto the stack, push a 0, and a 1, you push a 1 when once you see a loop of, or a sequence of closing parentheses. Once you're done, you would put, once you see the next opening parentheses, that's when you would push a 1. And on another stack, you're going to push the amount associated with that 1. And the idea is you're going to have an integer that tells you like what the total maximum is, like the return value, right? The longest one you've seen so far. And what's going to happen is when you pop your stack, when you process closing parentheses, you're going to start from 0 and you're going to increment by 2, right? So every closing parentheses, you sort of have a longer sequence. And if you have a closing parentheses and you end up seeing a 1 following your 0 somewhere, so after you pop a 0, you just check the top of the stack to see if there's a 1 there. If there's a 1 there, that means that you've now basically, what that would mean is now you've extended, you've sort of popped into a previous sequence. And so you'd add that to your total. And every single iteration, you just compare your current running amount to the greatest total so far. And then as soon as you stop popping, if there's something in this, actually not even if there's something in the stack, as soon as you stop popping, then you push another 1 and push onto the stack the previous, your new value. So when you pop a 1, you pop from the other stack that has all the things that you've been keeping track of. So I'll code it. Hopefully it makes a little more sense. I realize I kind of glossed over some of that. We actually will use a stack instead of a vector. I don't think we even need a vector for this. So we'll have a stack of integers, and we're going to say previous vals, and we're going to have a stack of bools, boolean bools, we'll just call it st. Yeah, and then we're going to say for const character c string if c equals an opening character otherwise c equals closing, and you're going to do 2 different things. Say equals 0. And we'll say if it's opening, then we're going to say st push 0, false. Now if you're popping, you're going to say st.pop, and you're going to have a current, which is 0. So when you pop, increment current plus equals 2. Say if st.if not st.empty, and st.top equals a true. So it's not empty, then we're going to say while, actually you do while instead of an if. And you're going to take previous vals, you're going to say current plus equals previous vals dot top, and then also previous vals dot top pop. I don't need the if statement anymore. And now you're going to say ret equals, so if ret is less than current, then update ret equals current. And you do this. So now what you want to do actually is not, you actually want to do something more like this. I is less than s.size plus plus I. Const character C s of I. And the deal is you actually want a while loop, so 2 while loops. So 1 while loop for while C equals this character. Then you're going to say so that's kind of tricky. This could just be an if statement, I think, because when you push a new, just thinking, yeah, you want the while loop to be the popping part. The pushing part, I mean, this could just be one at a time. That doesn't really matter too much. So you could just push. I don't think you do anything when you push. I think you just push something on. I think all the action happens when you're popping. So now we'll make this a while. And that makes things interesting. And then at the end of it, so we do this. We're actually going to update. You're actually going to update I. So something tricky here is we're actually going to have like a double loop in here. And we're going to update I based off this double loop. Now, the part of this that's kind of awkward is we're going to update I once here, but also we're going to have another while loop. It's like we could probably code this in a different way so it's not so awkward. But we're gonna kind of go with this sort of awkward way of doing it. I think you could do something like this. right? And then, no, that doesn't really work. No, it's fine. We could use I. It's okay. I think it's fine. So what we're going to do is we're going to increment I at the end. And then as soon as we break, we're just decrement I. Just decrement I, because you're going to increment I again over here. And so you have, this is sort of a for loop. But it starts off with this initial value. Sure. And then you would say, you know, if. This is so awkward. I don't know. This is really awkward. Yeah, I mean. Yeah, that's awkward. I don't know. It's kind of awkward. We'll come back to it. We'll figure out. Yeah, okay. And then you would decrement I at the end, so you process the last character again. That's so confusing. Yeah, because this goes off the edge. What happens actually if you? Oh no, actually this can cause an infinite loop, right? The infinite loop, because you go to the, it's less than the size. This happens, you enter the loop. Oh no. Well, once you exit the loop, it's gonna, yeah, that's fine. It's not infinite loop, not an infinite loop. But anyway, so yeah, you keep popping, keep adding. If you see anything at the top that's a true, you're gonna pop that. You're gonna pop the previous value, and then update ret. And finally, at the end of this, so when you stop popping, right, so actually it should happen here. When you see something that's not, well, yeah, I guess ultimately it is here. So what you're going to do is you're going to say previous values dot push back current, and then you're going to say st push true here, something like this. Yeah, interesting. I don't know, something like this. See how we do. How we doing on just to compile? Let's start with that. Oh, push. How are we doing with time? 13 minutes? Oh, okay, that's correct in this case. All right. Nice. Runtime error. That's always good. That's always good. It's definitely the middle one. I don't think it's this one. I think this one just immediately returns. Yeah. It's definitely because I'm using a really awkward loop here to do this. Let's see. Why is that happening? Yeah. Tempted to put some of this code over here. But it doesn't really matter where you put it exactly. So probably the I at some point is having issues. Or the top is having an issue. That could be it as well. Yeah, the popping and the pushing and whatnot. The stack's not empty, and there's a true on top. You pop that, and then you also take the previous top. These should be popped together and pushed together. That's interesting. This should be true. Where is the issue happening? Well, let's just put some debug statements in there and find out. I wasn't expecting that. Yeah, it's just, these are some awkward loops. Say, yeah, check. How are we doing on time? All right, let's take a few minutes to debug and, oh, immediately, okay. So push, and then here, I is less than a size, s of I equals this one, we pop, stack, increment current. Oh, you know what? Well, if it's empty, it doesn't matter, right? I don't have to add anything. No, that's fine. Oh, because, yeah, well, oh, no, I'm sorry. This is true the first time. Oh, I see the problem. It's kind of subtle. Oh, got it. I mean, there's that. That's kind of subtle. Yeah, I mean, we just push 0. I mean, that's fine. Pushing a bunch of zeros, not a really big deal. Not great. It's a little bit of a waste of memory. Oh, we're wrong now. Uh-oh. 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 Oh, I see. Oh, that gets really confusing, yeah, because we get a bunch of trues in there. And, yeah, that is confusing, actually. This should be, yeah, it really should be this, I think. I don't even enter the for loop. Yeah, because the issue you run into is, okay, this is like super awkward way of doing this, but yeah, this is kind of a problem. Okay, interesting. It's still wrong though. Okay. Huh. Okay. Let's ponder this for a moment. So we get our closing parentheses and the stack is empty. So we would skip the first one altogether. Then we get opening parentheses, push on the stack, closing parentheses. We pop, increment by 2. This is still empty. This is empty. Update to 2. Push this. Right, because the next value is opening parentheses, so this would exit. And so we push 2. And oh, I made a mistake. I see the issue. I need to update current to 0. Also, I missed that. That's a subtle thing. Got it. All right, I think that's correct. We can go for a bunch of different things here. I think that's it. I mean, there's like not a lot to say about this. I mean, it's not the cleanest code at all. It's pretty ugly. I think it's correct though. Also, I think we just get stuck. Oh, okay, we got it. All right. Yeah, let's just put a bunch of stuff in there. Something like this, I don't know. Let's try some random things. It's kind of tricky in terms of like coding it. Oh, we're wrong. Ooh. Which one? The third one? Oh no, there's definitely a lot of, third one from the bottom. Definitely a lot of like edge cases, I guess. The theory is pretty simple. Whoops. In theory, this is the way to do it. In practice, it's a pain in the neck. Is it this one that was wrong? I get the basic idea. Okay, so the question is why. All right, we'll just print like what red is each time. I think I know what the problem is. I was kind of hoping this would do this a little bit quicker, considering I already know the answer. So expected 26, not 28. Okay. So get this 1, 2, 3, 4, and then closing. So that should be basically, take that, just stays at 4, and then we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and someone here is 25, 26. I guess these two, and that should be it. But somehow, yeah, let's print I too. We don't need those actually. Okay, let's try this now. $30. So we hit 30, and then we add 4. Now that wasn't what I was expecting. Why are we getting? Let me print like the substring up to that point. So s.substring of I, something like this. Does that work? What does that give us? How do we do it on time? Okay. Oh, okay. I guess I plus 1 is the number of characters. Okay. So this is, so 0 up to this point. This should be 2. Well, after we process, we get 2. Yeah. We should have 4 when we start the next one. Still 4. Can we do? Can I actually do it the other way? Just want to see what the ret value is afterwards, after processing. So, oh, that's awkward. Excuse me. Excuse me. All right. I guess we don't have to have a new line here if we wanted to, but let's not do that. We'll just have a new line. So 0, 2, still 2, 4, 4, 4, 4, still 4, still 4, still 4. Get these two, it's 2 to 4, so it's still 4. 4, still 2, 4 and 4. Now we have 6, so update to 6. Update, whoa, put us at 16. Okay, no. How do we go from 6 to 16? That's not correct. How did that happen? Whoa. Oh, I see, because we processed these. So we had 6, we get 8, then we processed these 3, plus 6 is 14. So we should have gotten 8 plus 3, right? Which 8 plus 2 times 3, which is 14. So this should have been 14. So somehow we got 6. So okay, that's wrong. That's wrong. Because, oh, I see. Because what was popped off the top is got to be. It's got to be only a 0 off the top. It's kind of obnoxious. Yeah. And not s.top. Yeah, it's really annoying. I don't like how I did this. I think this is way too complicated for how I did it. In other words, you could have stuff, you could have junk on your you could have junk on the top of your oh, I see. Right. Now it's way too much. You could have junk on your stack, so we need to kind of be clear about what we're popping off the stack. Oh, it's annoying. These need to be falses that have been pushed on the stack. How do we get more now? How did that happen? What? What? Oh no, it's taking way too much time. Also, not coding it correctly. It's good. It's always good. How do we go from 6 to 18? So 1, 2, 3, 4, 5, 6, 7, 8, and then there's should be 6 more. So when we push these 3 on, pop 1. We shouldn't touch this one, right? Like, or no, immediately, yeah, immediately this stops after the next character, right? So this goes 1 character deep, pops and stops there. We process. And we go to another character. So this goes to 2. We process. Current goes to 0. We get here. Update current with what's on top with the 2. That goes to 4. So 2 plus 2 is 4. Push that on 4. 6. Now we get to the. Now we have 6 at this point. Once we see this one, yeah, we should have 6, and we should see 4 of these. 4 times 2 is 8 plus 6. We should get 14 here, not 18. I don't know how we got 18 there. We could just debug and just see. Obviously, this is like not the best way to code this. There's definitely a much better way to orchestrate this. So that way it's not like so messy. I don't really know that offhand though. It seems like the kind of thing you need to kind of practice to get it right. All right, so we hit this point, we hit 6, and we say, okay, 2 just jumps right to 10. Of course it does. Like that's how that works. It just goes right to 10. What? What? What is what? Oh, that is too funny. Okay. But how does that even make sense? Oh, that's great. So, okay. So when we're processing here, right, previous top is 2, right? When we get to this point over here, we say, okay, current 2, ret 4, get to this one, process, current 2, previous top is 2, right? This one that was pushed on is 2. And then, okay. And then now we push, should be 4 now. Process this one, should be fine. Now we process this, previous top is 4, 2 plus 4, right? That gives us 6, so we expect. Then here, we, so 6 should be on the top of the stack, and we push this new opening parentheses. Now, when we process this closing parentheses, we go through a litany of things, right? So previous is 2, previous top is 6, we add 2 and 6, we get 8, which we should, and then we should add, no, these 3 we're going to process as well. So current somehow just jumped straight to 10. How did that happen? What? What? Where did that occur? Huh? Excuse me? So, oh, this looped. How? Yeah. Oh, I see. Yeah. We got 8, and then we said 3 times. So it goes from 8 to 10 to 12 to 14. Okay, but that's the problem. The previous top is still there, though. That's an issue. I see. Yeah, that's part of the problem. So when you, I see. So when you see closing parentheses, it should kind of break things down. I think that's part of the problem. I think I'm not, actually it is a logical error. We're not processing the when you have too many closing parentheses, it should just kind of like break the should kind of break down the should kind of break down the stack. Like we shouldn't keep these previous values in there. Yeah, I think. Yeah, you should actually clear the previous values, I think, if you see that. We'll do one more else if. We'll just say else if stack, not the stack, yes. We could do, yeah, if the stack is empty and C is equal to this closing parentheses, then we're going to say, can you clear? Clear. Well, yeah, you could do something like this. Actually, I have an idea. Just do a while loop. While, well, as, No, actually, I'm doing it wrong. I actually kind of need to do something like this. So, I don't know. This is like way more complicated than it needs to be, though. There's definitely a better way to do this. So if this is happening, and you're going to do some things. Okay. So if C is equal to the closing parentheses, now what we can say is move any values what can happen is, oh, this is so confusing. Oh, it's so confusing. No, oh, I guess done. Oh, the way I've constructed this is so poor. So the logic you need in addition to what we already have is when you're popping these parentheses, the closing parentheses. So actually, we could consider an opening parentheses as the end of the closing parentheses. That's probably better. We really should just put this in an if-else, if and if-else, or an if-else statement. I think it's better. Do all that processing that we just described when we actually get to an opening parentheses. But when you're closing parentheses, if you happen across basically too many closing parentheses, then you just need to dump everything that you've seen so far. That's kind of the issue. So yeah, so we can do this. So we'll say we'll do this. We're going to put these things in put this logic in this part, some of this. But this we're going to put in over here. So previous values, push current 0, push true, and then push false, right? Yeah. And then we pop, we're going to say if st.top is true or is false, and this is the normal condition, otherwise we do something else. Now we're going to say in the normal condition, we can pop, we can increment the current value, and we can do this check. We can also say if, now we have this while loop here. While there are things at the top of the stack that are ones, right? So other things that have really should just be the previous thing we've seen so far. Oh, it could be more than one, potentially more than one. I think, yeah, it could be more than one. Yes, no, it's fine. No, it's okay. There could be more than one. That's true. I think. I think so. We're going to perform this operation and then do our check. Fair enough. So then now if the thing at the top is a 1 or Or if you're empty. So if it's a 1 or it's empty, then we're going to, that means that we need to just dump the things in the past. So while st empty, we're gonna st.pop, or yeah, we'll just dump both. Something like this. I think that's all you need. I think it's a lot easier to think about in the code. I'm afraid to actually delete all that though. Yeah, it should be fine. This is much cleaner. If it works. Big if there. Wrong. Nice. Nice. So right on any of these? Also, how far off are we? Oh, way off, huh? Not what we're expecting. See if we're right on any of these. Oh, we're correct on those. Okay, that's interesting. Is the logic just wrong? Is that it? Where do we get stuck? I think the if statements, I think I need to fix this. Let's use some else ifs. So if it's, this stack is empty, then we don't really care about this. I don't know. I'm actually not sure. All right. So when we get to this point here, we have this one. This should pop the stack altogether. Don't have all of our printouts, huh? It's a good thing I didn't delete this. It's a good thing I didn't delete these. Current and previous top. Interesting. So 8 then jumps to 10, 12. Oh no, this previous top has a 4. So that should have been gone. I don't know why. I don't know how that happened. Where we're here. All right, so we get to here, and somehow previous. How does that happen? Excuse me. What? Oh, because we push true after every. Oh, I see the problem. Yeah, I think we just push true after every opening parentheses, which I guess is fine. Yeah, oh, I see. Okay, got it. Got it. When do we clear? We clear when process this. The clearing should happen here. Current 4, ret 4. Let me think. So what's going on? Oh, okay. This is a lot of time for something that I already solved. I guess I didn't really solve it. I kind of thought about an idea, but it didn't really work because it's kind of tricky to get the sort of the lengths correct, I guess. I don't know if you really need a stack of, yeah, I guess you kind of do. I don't know. So the problem is that when you see this one, opening parentheses, closing parentheses, and you pop, and you see another closing parentheses, and you say, okay, this stack is not empty. Where do you end up in the second closing parentheses? You end up here, which is fine. Let me just see something. I think this logic is kind of faulty. There's like too many things I'm trying to do at once, I think, with the loops and the branches. Okay. Check 10, check 20. So that's kind of interesting. So it does get cleared. Okay, that does happen. It's 4, it's 4, it's 4. We get current 0, current 10, check 10. Current 0, check 10, ret 4, current 0, previous top is 4. Yeah, here previous top is 2, previous top is 4, we should get 6 for ret, right? Here we get previous top should be 6, we should get 8 for ret. Now here, ret goes to 10, ret goes to 12. Now what's interesting is that ret's 12, current's 12, but previous top is 4 somehow. Now I don't know how that happened. Like, where did we get that? What is going on? What is the? It's one of the reasons why I like to use the vectors for the stack, so I could like read everything that's in the stack. I wasn't expecting that. So we hit check 20. Both stacks just get cleared right out. So it's actually just misprocessing this part. I think it's because of this logic that I added, this extra true in here. So every time you add a true value and you push the current back, when you see another opening parentheses, right, because you have multiple opening parentheses, add a bunch of zeros. Then you close, and you add, nothing really. Then you open. Now what I'm wondering is, I'm wondering if these 4 came from here, or if it came from something in here. I think it actually came from here somewhere. Somehow I think we didn't clear the whole thing, which is really bizarre. Oh, you know what? I think I see the issue. Because you don't update current. That's why. I see the problem. Yeah, it's really subtle and really obnoxious. Really annoying. There we go. Got it. Alright, let's try this. I don't like how I did this. I feel like I should have been able to do this a lot faster. It's kind of a simple thing. Do we get all the debug statements? I think there's one more. Getting ready to run this on the tests. These debug statements. All right. Let's see. So there was a fundamental flaw in my logic. Looks like we're okay for now. I don't know. I mean, there's got to be some test case somewhere that we're missing. Excuse me. How about that? I'm just thinking there's some kind of like off by 1 error that I made somewhere. Something silly. Alright, we'll go for it. Nervous about this one. Oh, hey, we got it. Sweet. Sweet. Alright. Nice. Not my best, though. It's definitely could have been better. 8 milliseconds. Alright, we're pretty slow. Comparatively quite slow. Yeah, I don't know. I don't know, man. I don't know. Yeah, I guess, oh, there's actually, there are a couple things you could do differently here. Don't really need that anymore. Alright, a little bit faster. I think pushing all these extra true values in there and then popping them off over here is kind of unnecessary. Just thinking. Yeah, so what can we do differently here? Because clearly this is kind of obnoxious, right? This basically is you're going to have a true false, and you're going to say, okay, see a false, we pop it, we see a true, immediately we're going to see another false, right, necessarily, which could have a true behind it, but it's just another false, so then we just process the next, I guess if it's opening again, or if it's another closing, then it's another false and another true, which is like, do we really need the trues behind these? Just thinking about it. Yeah, I don't know if we even need the trues there. I'm just trying to think. I mean, at that point, you just pop what's on the top and add it, right? You could probably optimize this without using the true values. Let's not use true values. Let's try to not do that. This will already be empty at this point, by the way. If you're not empty, then right, we don't need that anymore, I think. And then I think you would just say, like, if previous values dot empty. Yeah, I don't think you need I don't think you need a loop there either. Like, I don't think you're gonna be in a position where you're gonna pop multiple, you're gonna connect to multiple things. Like, you're only just connecting the thing right behind you, or the thing that you just processed, or yeah, the most immediate section. And if there's one to connect to, yeah, which is there probably is. Something like this. I don't know. This probably won't be correct. Oh, maybe it's correct. Hey, okay. Great. Nice. That's a little bit better. Interesting. Right. So push the current and false. That's interesting. This is always gonna have a value. It's really interesting. Really not very efficient to use booleans at this point then. Yeah, the point of the booleans is to make things more efficient. That didn't make things more efficient. It's actually useless. Yeah. So really, you could just say if there's a previous value there, then take that previous value too. This is yeah, you could do this too if you wanted to. I mean, it's simpler, you know. Let's call it stack. Something like this. How about that? Okay. It's a little bit better. I'm not entirely sure how I could make this faster. I guess these integers could be smaller, certainly. Yeah, the idea was to use booleans, and then you can figure out which. I think part of the issue is that we're pushing onto the stack at every one of these, which really don't need to do that. Yeah, I mean it's relatively efficient, but it's took forever to code. Something we're missing here too is yeah, we don't necessarily need to push every one of these onto the stack and then pop the stack at every spot. That seems kind of redundant, kind of a lot of extra work. Could do something like, you know, what the previous character is or was. And do it that way. Oh, this is so tricky. So much easier to just have the integer there every time. There's definitely a better way to do this. I'm kind of disappointed now. I thought I had this too, like just in the bag, just no problem. I mean, yeah, this is just like not the most optimal way to do it. Definitely not. I thought I could think of like a more optimal way, code up in a more optimal way. Yeah, that's interesting. Huh. Maybe we could do. Say if current is greater than 0, then we push something onto the other stack. We could try that. That might be better. Let's just go for that one. Okay. Do something like that. Current's greater than 0. And then we'll do these 3 things. How about that? That might be a little bit better. And then now we can say, now we're just processing mostly bools. And now we can say if it's not empty, now we can pop from it. And this is previous value is not empty. Now, tricky thing here is we would say if st is not empty, and then maybe we do something like this. Something like that. Something like that ought to do it. No, we're wrong. I'll go way too high. That's interesting. Now maybe we need to do this now. Okay, let's find some of these that are wrong. So number 2 is wrong. Definitely gets way more complicated if you try to definitely gets way more complicated if you try to optimize this, I guess. So we get 6, expected 4. Okay. So current 0. So so the initial case is empty. So we empty everything. So current to 0. Okay. Then initially current's 0. We push. We see this now. Current goes to 2. Pop this false thing from the top. And you say if it's empty, which it should be, skip that part. Ret goes to 2. And then we move on to the next one. That's the closing part. Then we go to the opening part. Current is updated to, so current's not 2 anymore. No, yeah, current is now, oh, I see. So that's a good question. Yeah, this doesn't really work, does it? Yeah, it doesn't really do what I think it was going to do. I'm trying to demarcate when you have your closing parentheses. So, yeah, because you can update your current sort of over and over. Right. The problem here is that we push current on this opening parentheses. Oh no, we're supposed to do that at that point. Yeah, and then on the next one we would pop. So we'd push, current would be 2, set it back to 0, process this opening parentheses, that's what we just did. Process the closing one, goes to 2, we should add 2, and then we process another one. Current will be 4 at this point. Now if the stack is empty, which it should be at this point, no? Open, close, oh, right, because we don't, Yeah, you'd have to say end, not st top. I think so. Yeah. I think this might be a little bit more efficient if it's correct. Big caveat on if it's correct, because I don't think it's correct. All right, the bottom one is wrong. Okay. Yeah, this is like way too complicated. It's just way too complicated. I think the first solution I had is fine. It's a little slow, but we need all of our debug statements. Yeah, because it's too hard to try to like gather up all of the what do they call that? Gather up all of the closing parentheses. Excuse me. You could try to process them one at a time, but the problem is that when you have a closing parentheses, yeah, you could try to use a boolean to demarcate like when the next integer is. But the problem you run into is trying to figure out how do you how to actually delineate without like just spamming symbols. Excuse me. I guess what I'm trying to say is like you want to excuse me. You don't necessarily want to push an integer for every closing parentheses. It's wasteful in terms of memory and speed. You only want to use integers for when there's a meaningful amount that was processed. Just 2 or more. I mean, anything more than 0 is meaningful is fine, I think. But why is that such a structure? Well, the hard part after that is then you also push a true value in order to denote when you actually want to process. I think I must have done that incorrectly. Let's see. So when this is not true, you pop it, and if there's a true value underneath, you're going to use that. And then now, if it's not empty and it is true here, we're saying we just dump the whole thing. All right, I guess I have to debug this to find out why does this not do what I thought it was going to do. Who knows why exactly? Okay. I don't know. I guess I'll just print the. We print the return value. I don't know. I think I might need to change the loop structure to give us more information. All right, it's been over an hour, 15 minutes now. I mean, we solved it already, but we're still trying to figure out why I got it wrong. So we got to 12, we never got to 26. So it looks like 0, 0, 0, which we should have. 0, 0, 0, 6 zeros, right? And then 1, 2, 3 should put us at 6. And then 1, 2, 3, 4, 5, 6. That should put us at 12 when we get there. It does, and then we should get another. Here we go. So this is tricky, right? So now we push this onto the stack, the 12, and then we would say, okay, 1, 2, 3, and then we would add. We would get 1, 2, 3 would be sort of pushed onto the stack. This you get 2, push 2 on the stack, get 2, then 4, push 4 on the stack, 6, 8, 10, and then now this is interesting. You at this point, right? This would give you 10. Then you would connect these two. And that should give you 12. This should give you 14, and this 14 should be added to the 12. And then it breaks down after that. Or I don't know what it does after that, but yeah, that's supposed to happen. So this 12 plus 14 never happened, which is interesting. No, we never had a moment here where we cleared it out. It just didn't happen. Excuse me. Yeah, that should have happened up here. Like this 12 should have been pushed here. I saw this guy, which I think it did. We do some processing. Oh, I think part of the issue is process this guy. It's not empty, and there's something on the top, and it's not empty. Part of things that should have worked at this point. Did we not push this on? Did that not happen? It should have happened here. Definitely should have happened here. Current goes to 0. We'll push true on there, push the value. Don't push that there. Don't push anything there. And then, yeah, process these things. So these 3 are processed here by these 3. Or sort of. It's more like these 2. So confused. So confused. All right, let's try this. I was expecting this to be a lot faster, a lot sooner, this problem, but so yeah, there we go. We pushed 12 on. That's supposed to happen. 2, 4, 6, 8, and then we get to 10. Right? 2, 4, 6, 8, 10. And we don't push 10 on because then we just process here. 1, 2, 3. Now this one should go to 12. This should put you at 14. And then also stop at that point should have a true when you process this one. But we just don't get to 26. What happened, man? What happened? Oh, I'm wondering if this, no. What? What's going on? Maybe this should be a while loop. Actually, maybe that's why. Oh, that is why. That's definitely why. I think that's why. No? Okay, a little closer. Definitely closer. To... Oh, no. No, that's not. Oh. No. No, that's not supposed to be that way. Okay, so it just doesn't work the way I'd like it to. Alright, I get it. Yeah, because now what's happening is popping it way too soon. Yeah, that's awkward. That's not supposed to happen that way. It's popping it here, I think. So confusing. Yeah, because no, that's not. It's not supposed to work this way. We'll just print the size. Oh, I think I see the problem. No. No, it's not. No. I don't know what's going on. Something bizarre is happening. I don't know what it is. I'm also gonna raise the volume a little bit, just so I'm kind of whispering here. People are sleeping, no doubt. So here we push 6, right, and then we're supposed to get 12 and push 12, which we do. Then stack size of 2. Right, on this one, we get 3 things pushed on there. Push 1 on. We don't pop it. Then here here we push it on, then we pop again, then push again, then pop again, then push again, pop again, push again, pop again. Alright, current 2, 4, 6, 8. At some point we're at 10. And that's when we push again. Or excuse me, no, we push on here, we pop once, and then right, that's how we go with 2 plus 8 gives us 10, and then we'd have 2 more spots to pop. Now this is not empty. There is something on top. It should be a false. So this should be entered 2 more times. So now that's really interesting. We don't see that 2 more times. That's really weird, and the stack's empty, so what is going on? This must have happened somewhere in between, I didn't realize it. I think maybe it's this piece of code. I don't know. That's the way these things work together. It's just way too confusing. I don't know. There's not like a simple way to get this to work properly. Yeah. Check 10 happens right here. Oh, look at that. Oh, I see. So that doesn't make a lot of sense. Why would that happen? Why would that happen after this one? Here. You pop this guy, right? No. Yeah, here you would actually pop this one. And yeah, the previous values, which is 8, right? And then, then you pop again, pop this guy on this one. So you're at 10, you go to 12, and then one more it should be. Right, stack size is 2. Where's current? Where's that print? It's so confusing. Yeah, it's really confusing not using indices and printing what we're processing at that point. Oh. So before and after we'll do here. It's taking forever. Alright, stack size 2, current total 10. Right. It's 12, and then you hit check 10, and that's 2, 4, 6, 8. So this one is 10. So on the next one after that, some reason we hit here now. I can't imagine why that would be. Because you always push a false. Stack's not empty, and the top is full. So I don't get it. I don't understand. We'll just say other stack size. I don't know what to call this. Don't really have identifying terms here. I'm just absolutely flummoxed. Flummoxed. Two, 4, 6, 8, and 10. The other stack size is 8. How did that happen? How did that happen? We're not pushing anything onto it. How is it increasing? It should be popping. That's really confusing. Also, what is going on? What? So I understand why we got to 4, then we go to 5. Pop 5. Now why? Oh, that's really confusing. I think the reason, oh, okay, I get it, I get it. I think the problem is that we're doing it backwards. I think that might be the issue. That might be the problem, or at least part of it. No. Oh no. Oh no, it's not right the first time. That's supposed to happen. Yeah, that's. Yeah, no, that's right. That's right. I was right the first time, but it's not working for some reason. It's driving me crazy. Brain's turning to mush. Trying to figure this one out. Why does the stack size just keep increasing though? It shouldn't be. It should pop 2 at a time. It should pop. Oh, well. But that's why. Oh, that's very silly. Oh man, that took a while. Oh, I see the problem. Okay, no kidding. It's most definitely my own fault. I don't know. I get kind of hung up from time to time on like timelines and what have you, and I just get kind of not stuck, but I kind of forget what I'm doing, I guess. Something like that. Oops. I say forget what I'm doing. I just kind of make mistakes from time to time. I don't even know how to say what I express it. How to excuse myself here. Do we go for it? I think we go for it. Oh, all right. A little bit better on memory. Not much faster though. Yeah, well, we had some expense there with the extra branch. Oh man, little to no benefit doing all that, by the way. Little to no benefit whatsoever. Yeah, okay, well, what can you do? So yeah, part of the problem is that you have extra branches, and obviously I completely forgot to pop the true value that's on the top. That was the issue. That's bad. Just missed it. Yeah, wow, it's actually slower because of the extra branch. No kidding. Alright, well, we'll go back to what we had. So yeah, we just push the previous card value and that's it. That's all I gotta do. Oh, wait, too far. There was a point here where what did we do? Is this it? Is this correct? It was something like this. Oh wow. Hey, 100%. There you go. No kidding. Interesting. Somehow we just randomly get 100%. Okay, very good. But yeah, you could just use st here instead of previous values. St current equals 0. It's not empty. Pop that too. Otherwise, pop the whole thing. What did we do? We just did like current plus equals 2, current plus equals st top. We pop it. And that was really it. Something like this, super simple, we had before. Yeah, I think that's it. Here we go. Somehow not as fast as the thing that we just had, whatever that was. Or I guess it's randomly not as fast. Why was this other thing faster? That seems so strange. So somehow this was fast. How is this faster? This seems like it would be slower. Yeah, this is slower. It's definitely slower. Alright. I don't know. Who knows, man? Who knows? Somehow this is slower. I mean, it's a lot easier to code, but somehow slower. Anyway. So yeah, thank you for watching. I think I'm gonna call it here. We did get 100%, but like, I don't know. I'm like often not satisfied with just getting like the 80%, 90%. Like I want to get the 100%. Pretty simple approach though. You just push onto the stack whatever the previous current value was and update that to 0 when you see an opening parentheses, and then when you see a closing parentheses, you just if there's something on the stack, you pop it. And yeah, I mean, you could just, don't really need two statements here, I think. Pop what's on top, and then this is kind of interesting. Actually, I probably could speed this up a bit. If it's not empty, if it is empty, well, I guess we don't really need to do this, do we? It's already empty. I think we just update current to 0 if it's empty. Just thinking, would current be 0 if it's empty? Yeah, I mean, do we even need this? I'm wondering. Maybe? I think we do. Yeah, we do. Okay. I want to optimize this slightly, so could take this branch and put it in here and do something like this. Could do that too. I'm not sure if that's much of an optimization though. Maybe, I don't know. Alright, we'll try one more time. Yeah, this logic is kind of stuck here. I'm trying to think if there's a way I could make this even faster. And this is super simple, this approach. Let's see. Almost 2 hours we'll look at this now. I don't know, this wasn't supposed to be... I don't know, man. Trying to figure out a way to do this with even less memory. Maybe we could just put current equals 0. No, you can't do that. You gotta do that you have to increment each time. I don't know, I think it's the best I got. There might be a better way. That gives you 100% consistently. Slightly better way of running this routine. Alright, I'm curious to see what the discussion says. I probably should move on though. Probably should just move on. Yeah. That's tricky. That's tricky, man. I don't know. I mean, I'll take it. 4 milliseconds is pretty good. We did get 100% at one point. It's kind of unlikely, though. Yeah, I don't know, man. I don't know. Let's try one more. No, man. No, I don't know. There's got to be some way to optimize this slightly, though. You could do else here instead of else if. That might make it faster. Forgot about that. Didn't even consider that. Yeah, not much better. You really want to get rid of one of the branches. That's the thing you want to do. Push all these zeros on there. It's fun. Yeah, I mean, this just handles everything nicely. I don't really have a better idea here. I mean, it's it's a hard problem, so I guess we got it. So we'll move on. That's okay. We got the idea. It's a simple idea. Basically just push every time you have a opening parentheses, you basically push your previous result there. And when you see an opening parenthesis, a closing parentheses, then you take whatever previous result you had, pop it off, use it, pop it off, and compare. And then obviously if you don't have any previous results, you just update your current value to 0, and then it's basically a dead set of parentheses. A little disappointed that I couldn't really think of a faster way to do this. I'd probably have to, I don't suppose it's a different algorithm, but it's kind of a different approach. It's the same idea probably, but slightly different approach. Using integers is kind of awkward. You don't need, you can use like characters, I guess. Use a lot fewer bytes maybe. Character I think is 8 bits. How far can we go with 8 bits? I think it's actually more than that. Let's actually try that. Let's see what happens if we do that. I'm very curious now. Let's see, is that faster? Oh no. Not quite. Not quite, not quite, not quite. I probably shouldn't have tried that. I got a wrong answer for no good reason. Let's see, ref int. Oh, 16-bit, huh? Can I get short? Oh yeah, okay. That's probably what I should have used as a short. Not a character. Yeah, character's a little too small. How about that? Or short int. 16 bits. Oh, hold on. 2 to the 16th is what? Maybe I was wrong. No, 65,000. This was it's only 30,000. Yeah, this should work. Yeah, I don't know, how did we... Yeah, uses a little bit less memory, not as fast. Not very much less memory. Yeah, characters. Characters too small, I think. 256, yeah. Just didn't quite cut it. Oh, pretty close. Pretty close. Excuse me. Characters can be less than or equal to short. Wow. So I think it's 8 bits. Yeah. Oh man. Short int. Maybe I could use an unsigned character. Oh, maybe that's what I need to use. What was that test case that I failed on? Oh, that's why. It was just a... Let's do it. I don't know, man. I don't think it works if we do. That's so funny. An unsigned integer. An unsigned character. It'll work for that case, but it won't work for other cases. No, it's not. You can't do 8 bytes. 8 bytes won't work, man. I think an int, short int, maybe we can do. I think either way, it's not going to work. I mean, it's got to use 16 bits, which I think is what we've been using the whole time. Yeah, it's not much faster. No. I mean, these could be short ends too. Actually, that might be part of it. That might be part of it. Converting between short ends to regular ends, maybe that's why. Oh, not much better. That's interesting. It's kind of random how much memory it takes, I think. Okay, we just randomly hit 100%. Alright. I actually think maybe it's because we're using short ends. I think so. I actually think that we are slightly faster using short ends. Yeah, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I don't know. I think it's random how long it takes. We got it a couple times. Yeah, okay. Alright. That's probably enough. We've wasted kind of a lot of time on this. Or spent a lot of time. So yeah, thank you for watching. Talk to you soon. Have a good rest of your night. Oh man. I need I don't know what to think, what to say. Like, sometimes I don't get like the exact optimal solution, and then I go into this kind of like tizzy of like, not tizzy, but I go into this like mode where I'm just like trying to figure out what I did wrong, I guess, and or what I could have done differently, could have done right. So yeah, I'm just gonna go. This is like really a lot of time for this problem. This problem's not that hard, not that interesting overall. But yeah, yeah. Thanks for watching. Talk to you soon. Have a good rest of your day.